Greetings. Welcome to Machine vs. Mathematics channel. Zeros cannot decide the fate of magnitude response of a system, but the same zeros can decide the phase response of a system. The location of zeros, the location of zeros inside a unit circle or outside the unit circle doesn't matter. Yeah, for stability point of view. So in that scenario, say you have a question like this asked in GATE ECE 2014 set 3 for 2 marks. Let h1 of z equal to this, h2 of z is 1 minus q z inverse whole inverse. Now h of z equal to are given like this, a linear quantity. The quantities p, q, r are real numbers. So p and q are given provided r must be less than 1. Modulus of r must be less than 1. Now if the 0 h of z lies on the unit circle, then r equal to. So there is no big deal in solving this. It is asked in GATE ECE for 2 marks. See, let's accept whatever is given to us. H of z equal to h1 of z plus r multiplied by h2 of z. Now let us accept h1 of z and h2 of z as well. So let's plug in here. So h1 of z is 1 over 1 minus p z power minus 1 plus h2 of z is what? So r multiplied by h2 of z. So therefore it is r over 1 minus q z power minus 1. Is that okay? Now yeah, this is what h of z. Now you simply go for its simplification. You get 1 minus q z power minus 1 plus r multiplied by 1 minus p z power minus 1 divided by 1 minus p z power minus 1 multiplied by 1 minus q z power minus 1. Alright, so further we can simplify this as follows. So h of z, so h of z is, let me put it down this way, 1 plus r, so minus q plus rp multiplied by z power minus 1 divided by 1 minus p z power minus 1 minus q z power minus 1. Is that okay? So therefore we have h of z as ratio, we have numerator quantity, they belong to zeros, and this quantity will talk about poles. Okay, so we need to focus not on poles as of now, because the question is the quantities pqr are real numbers. Now the fact is that if the zero h of z lies on the unit circle, then r equal to, provided p and q are given like this, and we obtain h of z as follows. Okay, now let me go for next page, and let us revisit the same form, that is h of z, the obtained form. We have, this is 1 plus r, 1 plus r minus q plus rp z power minus 1 divided by, you have 1 minus p z power minus 1 multiplied by 1 minus q z power minus 1. This is what we obtained, right? So we have this fellow in our hands as of now. Now 0. Now the 0 is what you have 1. If the 0 h of z lies on the unit circle, so let's go for it now. So let me go for, okay, red. You see, let me take my z plane. This z is a complex variable, so therefore it is a complex plane. So z plane. So I have real part of z and say imaginary z. So let me draw a unit circle. Say let me draw a unit circle, means radius must be 1. So this is my unit circle. Alright, so whose radius is 1. Now what's the question to you? The question is simple. The question is, if the 0 h of z lies on the unit circle, okay, lies on the unit circle, so I'll take real quantity. So I have a 0 here. Either I can take 0 here or I can take here, right? Circle is of unit radius. So now in this case, say this is g1. So this g1 equal to 1. So in this case, say it is g2. This is -1. Okay. So now we will try to find out zeros from this and we will equate to this. Okay. Because he gave 0 lies on the unit circle, we will equate to this. That is case 1. And again, for the same zeros of h of z, we will equate to -1. Okay, this is a case 2. Now in case 1 and case 2, we will try to find out the value for this r. Okay, now that value should satisfy whatever value we get in case 1 and case 2, that must satisfy this condition, r less than 1. Okay, modulus of r less than 1, that has to satisfy this. Now whoever satisfies this condition, that fellow will win. Okay, and that is the answer for this r. And see, it is as follows. Now this is what our obtained h of z. Okay, now from this obtained h of z, how do we find zeros? Just put numerator equal to 0. If you put numerator equal to 0, you will get zeros of h of z. So therefore, I want to find zeros. Okay, so zeros of h of z. All right, let me put that numerator 1 plus r minus q plus rp multiplied by z power minus 1 equal to 0. So this is equal to 0. Just a minute. Okay, so now what can we do? So we can do like this, that is q plus rp. Just simplify this. Q plus rp multiplied by z power minus 1 equal to 1 plus r. All right, so now z power minus 1 equal to 1 plus r divided by q plus rp. So therefore, what is z now? Z equal to q plus rp over 1 plus r. Now we'll go for case 1. Okay, now what is case 1 here? Let us go for case 1. Case 1, we will take z as z1, that is equal to 1. So therefore, if I take like this q plus rp, because he gave zeros of h of z lies on unit circle. Okay, so therefore I'll take zeros of this lying on unit circle as positive 1, just 1. Okay, now you find for this. Now q plus rp equal to 1 plus r. All right, now what is given to us? Now given to us p is equal to half and q is equal to -1 by 4. So you plug in q equal to half. So if I plug in p is equal to half, q is -1 by 4. So q -1 by 4 plus r, p is half. So therefore it is r by 2. So this is plus, this is plus 1 plus r. So therefore what we get? So we get minus 5 by 2 equal to, this is what, minus 5 by 4. Okay, you see, minus 5 by 4 equal to r by 2. So now what is r here we have? So r is -5 by 2. So in case 1 we obtained r is -5 by 2. Let's go for case 2. We'll compare case 1 and case 2. We will see who will win the race. Okay, now case 2 is what? Zeros of h of z. Given zeros of h of z lies on unit circle. So this is possibility 1 and this is possibility 2. Okay, so therefore if I take possibility 2, that is z2 equal to -1. So zeros of h of z lies on unit circle and this is possibility 2. So therefore you have q plus rp. So q plus rp over 1 plus r equal to now -1. Okay, so you further simplify this. So q plus rp is negative 1, negative r. So you plug in the value for q. So it is given negative 1 by 4 and plus p is given positive half. So therefore p is equal to 1 by 2 and this is minus 1 minus r. Okay. So just simplify this, minus 1 by 4 plus 1. So you get now 3 by 4. So 3 by 4 and this is minus r by 2. Okay. So you can just find it out. So you will get minus 3r by 2. Alright. So you can further simplify this. So these two are out. So finally r is equal to negative half. Okay. So in case 1 we obtained, you see, in case 1 we obtained r is negative 5 by 2 and in case 2 you have r is negative 1 by 2. So now which case do you think won the race? Without second thought we could say case 2 won the race, because you see r is negative 5 by 2, right? In case 1 we obtained r is negative 5 by 2. This is nothing but minus 2.5. Okay, in case 2 we have r is minus half. There's nothing but minus half, right? So minus 2.5 minus 0.5. The condition to be satisfied is what? The condition to be satisfied is r must be less than 1. Alright? So r must be less than 1. Who is less than 1 here? Negative 0.5 or this fellow? Yeah, obviously I can go for this one, right? Less than 1, because he is not, see, because you see, you know the basic definition of modulus, right? See, for example, if I take modulus of x is equal to positive x for x greater than or equal to 0. Okay, and this is negative x for x less than 0. Okay, now you put it down here, you must get this. Alright, so therefore now this fellow satisfied. Now what do you think is your answer? Now what is the value of r there? Yeah, so now what do you think is the answer? What is the value of r? Yes, you can go for, you just need not go for any second thought. So this is the possible case we have. Okay, and that's it. So that's it for today. It's very simple to solve. There is no big deal in this. So then r must be negative half. All right, so that's it for today. Thank you.